Today's video is going to be looking at special segments in the coordinate world. So we're looking beyond the triangle. We are looking at the triangle, but we're looking at the triangle with coordinates versus the segment expressions and things like that. So we start with triangle ABC has the three given coordinates. If AK is an altitude, what is the slope of AK? So what I want to do is I want to clarify what this is going to look like. So I start by drawing my triangle. If I don't have a picture, I draw a picture. So I've got triangle A, B, C. A is at 6, -1. B is at 8, 3. And C is at a -4, -7. So AK is an altitude. K is not on my diagram, but I know what an altitude does. I know it's coming from A. So if I go from A down to K, we know the properties of the altitude is that it's forming the right angle. So altitudes are right angles, and we know that right angles are formed from perpendicular lines. So we want to think back to how do we know what perpendicular lines are, and we think back to slope. So what is the slope of AK? We know that perpendicular lines have opposite and reciprocal slopes. So if AK is going to be perpendicular to BC, that means AK's slope is going to be the opposite reciprocal slope to BC. So I start by finding the slope of BC, and we know that our slope formula, we subtract the y coordinates on top, the x coordinates on the bottom. So we've got -7 minus 3 on top, and then the x coordinates on the bottom, -4 minus 8 on the bottom, gives us a -10 over a -12. We always reduce down, which gives us 5/6. So the slope of BC is 5/6. Because I want the slope of AK, which is perpendicular, the slope of AK is going to be the opposite and reciprocal. So the opposite of positive is negative. The reciprocal of 5/6 is 6/5. So it's a nice little refresher from our Unit 1 when we dealt with slopes. Our next special segment, a triangle ABC, AK is a median. So again, we think about what a median does. A median is connecting to the midpoint. So we want to see what's happening in our diagram. We don't have a picture, so we draw our picture. Triangle ABC. A is at 5, 4. B is at a -3, 6. And C is a -1, -8. AK this time is going to be a median. And a median is going to create from the vertex to the midpoint of the opposite side. So if it's the midpoint, I know those two segments are going to be congruent. So since it's a median, K is the midpoint of BC. So now we're going to refresh our memory on the midpoint formula. When we are doing the midpoint, we are averaging the x's. So we add the x's, and then we divide by 2. We add the y's, and we divide by 2. So that gives us a -4/2, a -2/2. So K is going to be at a -2, -1. Again, a nice refresher of our midpoint formula that we talked about in Unit 1. It's important to draw the diagram so we can see which information we need to utilize. Notice that we never use point A in that particular problem. We're not going to use all the points. We need to see in our picture which one is going to be valid. So triangle ABC with the following vertices, if F lies on BC and is located at 3, 2, is AF a perpendicular bisector? Lots going on here. So we again start with our diagram. We've got triangle ABC. A is at 1, 0. B is at 4, 1. C is at 2, 3. F is going to lie on BC. And F is on BC, and F is going to be at 3, 2. the question it's asking us is AF a perpendicular bisector? So we're looking at this segment AF and we want to find out what is the relationship of that segment. Is it a perpendicular bisector? Perpendicular bisector has two properties. The first word here we see is perpendicular. So because it's perpendicular, if it was a perpendicular bisector in this case, then we would need AF to be perpendicular to BC. So we're going to check, do we have opposite and reciprocal slopes? That's what we're trying to figure out. The second thing here is that we have a bisector. That word bisector would mean that F is the midpoint of BC. So if it was a perpendicular bisector, it would have both of those properties. We need to see, does it have both of those properties? So we start with the first one. Is it perpendicular? So we need to find our two slopes. The slope of AF, we subtract those y's on top, so 2 minus 0 on top. Subtract the x's on the bottom. We get 2 over 2, which gives us a slope of 1. I'm looking for the other segment to be opposite and reciprocal. So the reciprocal of a positive 1 is a negative 1. So we're going to look at that slope of BC and see if we get what we need. Subtract the y's on top, the x's on the bottom. We get 2 over a negative 2, which is a negative 1. So we just found, yes, AF is perpendicular to BC. So we've fit the first criteria. The next thing that we have to check, though, is F, the midpoint of BC. So we have F at 3, 2. We want to find out, is 3, 2 the midpoint of BC? So if I go to do the midpoint of BC, remember we average the x's, so 4 plus 2, we add the x's together, divide by 2. Add the y's together, divide by 2. That gives us 6 over 2, 4 over 2, 3, 2. The midpoint of BC we found to be 3, 2, and the coordinates of F are 3, 2. So yes, F is the midpoint. So in order to be a perpendicular bisector, it had to be both of those, and we were lucky it was. So we can draw our conclusion that yes, AF is a perpendicular bisector of BC because we found AF to be perpendicular to BC and F is the midpoint of BC. It's important to remember that it can't just be one of them, it has to be both of them. The perpendicular bisector holds both properties of the altitude as well as the median.